All right, here we go. Last training of the virtual roadshow. We made it. Thank you, everybody, for sticking with us for these past 4 days. It's been an incredible experience for me. I really can't thank you guys enough for being with us these past 4 days. The roadshow actually extends, though, into the weekend, as you can continue to earn points by going to the virtual booths, by looking at the recorded versions of what we just did over these past 4 days, and then also going to the arcade and playing games. You keep racking up those points until Sunday night, and we will hit your account with all those points on Monday, where you can use for all of our sponsored vendors that were in our show this week. So again, thank you for everything. This has been by far our best virtual roadshow ever. So we thank you. So let's end with fiber. This is something that has technology has grown, right? I mean, with the speeds and transmission, we want to make sure that we're running fiber in certain applications as technology grows and develops. And Robin Roy's here with LYNN, formerly Technologics. Now it's going under the LYNN NSI name. Is that right, Robin?
Yes, we are known now as the Network Infrastructure Division of NSI Industries. And so that encompasses LYNN, Technologics, which actually will go away, Platinum Tools, and eNet.
And speaking of Platinum Tools, real quick, we have a promotion right now that we just activated. Really, it's for the roadshow. We're going to also continue it. If you buy 2 jars of connectors, the EZEX connectors, you get a free crimp tool. So that bundle is live on our site right now. Make sure you take advantage of it. But yeah, Platinum is under the LYNN NSI umbrella, right?
Yes.
So you're gonna walk us through the basics of fiber, kind of how to terminate it. If you haven't done it before, it's not as daunting as you might think it is, right?
No, not at all. I find that people have more trouble understanding fiber, what it is and when to use it. The terminating it's actually the easy part. It's the understanding it that it gives you a little more trouble. So yeah, let's talk about fiber. So we all know that fiber is becoming more and more relevant in our market today. No longer is a Cat 5, really, or Cat 6 even viable for the equipment that we're offered today. We're finding that Cat 6, Cat 6A, and then even bigger is what's more, called for. And so Cat 6A, natively capped at 10 gig per strand, just doesn't cut it for some applications. So that's where fiber comes in and plays a major role, because you can accomplish that bandwidth and distance that you need with a single strand of fiber most often. So let's talk about the differences between fiber, because most people don't understand the actual differences between the fiber. So single mode and multi-mode, what's the difference and when do you use which one? So single mode is what we call a 9-micron core. As you can see on the PowerPoint, it's very small. Multi-mode is a 50-micron core. So there's a big difference between 9 and 50. So a mode is just a beam of light. So a multi-mode is just multiple, beams of light going into this 50-micron opening. So multi-mode, because it has several beams of light and it's a bigger core, we find that once it goes in there, it starts moving around because it's got a lot more room. And so it will start to bounce and reflect off the sides of the walls of the fiber. And once it gets to a distance of 1,800 feet, it's bouncing so furiously, it's no longer viable. So it's capped at 1,800 feet. And that's very important when you're speccing your jobs, to know that multi-mode is capped at 1,800 feet. It also is capped at 10 gigs per strand. We'll talk a little bit more about that in a moment, but it's just important to know that, for projects, multi-mode is limited at 10 gigs per strand up to 1,800 feet. Now, single mode, on the contrary, it is a much smaller and tighter core size. And when the beams of light go in, it doesn't have that room to move around. That's why internet service providers use single mode most often, is because it's unlimited in distance and unlimited in bandwidth, and it's really great for using, longer distances. And so most people will ask, well, why don't we just use single mode for everything? Well, the reason is because of the cost, right? Every time you add 10 gigs, it becomes exponentially more expensive. And so if we were building everything to single mode, then the cost would just be a lot more. Right now, historically, multi-mode fiber might cost a little bit more, but the equipment is cheaper. And so with single mode, it's the opposite. The fiber, because we make so much of it, is cheaper, but the equipment, because it's unlimited in bandwidth, tends to be a little bit more expensive. But we're finding with the industry growing, manufacturers are starting to build more towards single mode. So I think that will come down at some point. It will kind of level out. Now let's talk about the differences. Go ahead.
Equipment. You're going with the equipment too, right?
I've got some examples. Yes.
The media converters, right?
Exactly. Network switches, SFPs. Exactly.
Okay. Yeah.
So on the construction of the fiber, so basically there's two types of single mode. OS1 just means one strand, and OS2 is everything else. So with single mode, it's kind of weird because that's all it is. With multi-mode though, there's different grades. So the old school stuff, most older telecom or datacom systems, they might use the OM1 or OM2, which were laser optimized. We still run into those, but they're no longer the modern standard. The modern standard is the laser optimized OM3, OM4, and OM5. The differences are, so OM3 is optimal, best performing up to 900 feet. OM4 is going to go up to around, 1,1500 feet. That's its sweet spot. OM5 carrying you all the way to the 1800. They will all work up to 1800, but they're optimal for each one at those distances. Now they're all pretty much the same quality or do the same performance at the shorter lengths. So we use multi-mode, like I said, on 1800 or less, but that's where the grades come in.
And you're running, you said companies like, or AT&T or providers will run OS2?
Yeah, pretty much, or OS1. I mean, OS1 just means one strand, so these are virtually the same thing. It's just one is one strand and the other one is how many ever strands you have in the jacket. Yeah, it doesn't make much sense there. So, but that's the way it is. Now let's talk about fiber infrastructure and what it takes to build a fiber system, right? So it takes bulk fiber, of course. We at our company, we are a Corning Gold manufacturer, so we can actually build the whole fiber run with the connectors and everything and have it available so that it is ready to just kind of plug and play. But if by chance people want to do it themselves in the field, that's what this will encompass, okay? So we have the bulk fiber, multi-mode or single mode. We also do specialty cables like direct burial, armor, tactical. Then we have the connectors. You'll need to know if you're doing single mode, multi-mode, or angled connectors. ST, we have several different types of connectors, but these are going to be the ones you run into most often. And I'll go into the descriptions of these a little bit more in a moment. Next, we have fiber enclosures. So that would be, the next thing in building a system. We've got plastic, indoor, outdoor, and then we also have the metal indoor, and we have rack trays, patch panels, pretty much anything you would need from start to finish of a fiber system is available. And then of course your patch cables, then your equipment, your SFPs, your switches, media converters, and then usually you have to throw in some type of category patch cables when you're dealing with these media converters and such. Any questions on the components of a system, Mark? That's pretty much what I find is involved.
Yeah, well, presenter be available to this presentation be available to us. So it's good stuff. So, what did you have? What is tactical?
Tactical. I'll give you an example. Like on our OSP fiber. Can you see me? On our OSP fiber, we have a ruggedized, just rigid type of outer shell on that. So we have some, we don't necessarily call it tactical so much. I know like on our MOFO cables, that has a tactical outer coating on it. And it's just something we refer to as more of a rigid structure or coating, if that makes sense.
Yeah, very good.
Okay, so real quick on the connectors, let me make sure. Okay, and this is where, sorry about that. So on the connectors, I wanted to point out the differences in these connectors. So we have the LC, which is also referred to as lucent connectors or little connectors. The SC, which are subscriber or standard connectors. And then these are ST. You're going to see the ST more often in old telecom or datacom applications. The LC and ST are what your dealers are going to run into most often. Really, the LC is going to be the most popular, and it's simply because for the real estate that an SC connector takes up, an LC you can fit two. So if anyone's asking, the LC is probably going to be the most common one that they are going to use. Okay, so moving on, I wanted to take a moment and show you some of the styles of fiber. I'm going to go over the construction of the fiber itself. We have the jacketing, the strengthening fibers, which are also referred to as aramid fibers or Kevlar fibers. These are very important. They help with waterproofing, but they also give strength to the fiber to keep it from breaking as easily. Then we have the coating. You'll hear me refer to this throughout the termination as the 250 micron layer. Then we have the cladding, which is a layer underneath the coating, which is pretty much we scrape it off and it looks like a residue. You'll hear me refer to it as a 125 micron layer. And then we have the bare core or the bare glass on that. And so that's the construction of the fiber. And I would like to show you some examples of that if you would like. So I'm going to run through these and then I'm going to show them to you. So simplex, when you're dealing with fiber, just simply means one. It doesn't matter if it's single mode, multi-mode. Simplex just means one strand, one jacket. Duplex or zip cord, you also probably will hear it referred to, is basically just two strands and they're in separate jackets that are fused together, kind of like a Siamese. So that's a duplex. And then we have distribution, which is in one jacket, multiple strands. It can be anywhere from 2 strands on up to, it's unlimited actually, but that's duplex or distribution fiber. So that's what you're going to hear most often when you're talking fiber with anyone. You're going to hear either duplex or distribution. And then these are just some of the connectors that work with those. All right, so I wanted to pause here, Mark, and show you some examples of the fiber. So do you need me to stop sharing?
I don't know. Let me see. Give me a second.
Or perhaps I could.
Can everybody see Robin now and not just her presentation? If you could respond, because you might need to stop sharing.
I'm going to, I'm sorry, I'm going to change cameras for a moment. And if I can, sorry about that. Okay. Because I want to get close up on this. All right.
There you go.
So some examples. Can you see it okay?
Yep. Looks like we're good.
So this is a regular distribution cable. Distribution meaning more than one in a jacket. This is a 6-strand. I also have an example of a 12-strand. what I would like to point out here is that there's not much difference in the diameter of the cable, right? So we have a 6-strand and a 12-strand. So if you were using copper, imagine the difference. You would have, 6 different bundles of copper, where with this, we have 12 strands of fiber in one jacket, and it's very small. And same thing with this, 6 strands. Now we also have, this is a regular distribution, but we also have a micro distribution. So I'd like to show you that. And so this also is 6 strands, but you can see the difference in the coating. This one has the 250 micron coating, and this one does not. They just color coded the last 125 micron. These are exactly the same types of fiber. They have exactly the same color coding. One is just without that center coating. So if you have a really tight application and you need 6 strands or you need 12 strands, we do offer it in a micro version of that. So I like you to see that firsthand so you know the difference in the diameters and what have. So that is distribution and micro distribution. Now I wanted to show you, because I'm about to talk about AIA, or aluminum interlocking armor. So this is what is referred to as your standard AIA cable, or aluminum interlocking armor. This is not to be mistaken. It is not waterproof. Just because it's armored, it just means it's protected from rodents and from being crushed. So this is your standard AIA. This also is a 6-strand, but then we also have a micro armor. So I'll show you the difference. This is the same function, but you can see the difference in the diameter. So this also is armored, but this is our standard armoring, standard AIA. This is micro armoring. And it also does the same thing. It keeps it from being crushed or eaten by rodents. It's just a lot smaller. Now, of course, it's a lot more expensive comparatively. That's why most people use the standard AIA. But I do like for everyone to know that is an option, because you never know what kind of circumstance you're going to run into. So that's AIA and micro armoring. And then we also have, want to point out the difference between, as I said a moment ago, this is distribution fiber, but I wanted to show an example of the zip cable or the duplex. So this is the difference between those two. This is a distribution and this is a duplex or a zip cable. So that's the difference. And they use different connectors. So it's important that you understand that there are differences between them. And the last style of cable I want to show is our OSP cable. Now these happen to be single mode. One of these is a 12-strand and one is a 6-strand, but as you can see, they're almost identical. What's unique about our OSP is that it has a stainless steel messenger. So what this allows it is that it can be direct buried, so you can tone for it in the ground, but it also is able to be aerial because of that stainless steel messenger. So that comes into play when you have like camera systems, or lighting, different things outside. But that's all the different types of fiber, that I usually show on here. So I'm going to go back to the PowerPoint.
Somebody asked too, like, I don't know if this is related to the armor, but how much weight, like a car, just foot traffic? I don't know if that's about how much weight.
So with what the regular AIA, I think a spool of that, maybe like a 500-foot spool, is around 80 pounds. Yeah, so it's quite heavy. Okay. So you do need to be aware of that when you're ordering your fiber, that you have to make sure you have a way to pick it up. So if you order a 1,000-foot spool of armored fiber, you're going to need a forklift, or you're not going to be able to pick it up, right? You have to have a way to move it. All right. So
this is just real quick before you go on. I should two more questions. This is always I always hear this. What is it? Splicing. What do you have? That fusion splicing.
Mm-hmm.
That's probably a lot more difficult than, I don't know if anything's changed, right? Don't you have to be like certified for that?
So fusion splicing is when you take a fusion machine, which is basically an element that heats up the fiber, and it heats it to the point of melting, and then you put the ends of the fiber together and it melts them together. That's fusion splicing. So the equipment for that is very expensive, right? But the good thing is our fiber that we sell, because we're Corning Gold House, is able to be fusion spliced. That's important if you're doing like government installations, schools, military. It has to be able to be fusion spliced, which ours is. But we offer mechanical connectors, infield connectors, which is a lot more economical and easier.
And that's probably the question they had. Can you splice it? And I think I asked about fusion splicing. It's just, can you splice the fiber? And that's probably what they're getting at.
Yep. Yeah. And so we do sell a little splice little mechanism. So the steps I'm going to show you to terminate the fiber, you would follow the same steps, and you would just do it on each end and then put it into the splice and click it into place. And I would be available to help anyone if they needed to learn how to do that. It's pretty much the same technique, maybe just some different measurements. Okay.
But it is what? Is it like another, is it just like almost like a coupler?
Yeah.
That you use? Okay. Yeah.
Yeah. Okay. They come in a 5-pack.
Great.
All right. So back to the PowerPoint.
I think you're going to get into tools too, but somebody asked what type of visual fault locator testers best to use.
I'm about to show you that as well.
Right. Okay. Go ahead.
How do I blow this back up? Okay. And it just disappeared on me. I just lost it.
There you go. It's coming up.
Okay. All right.
You have the wrong screen up. Join as a panelist, so you have to go to the right screen.
Let me stop this and I'll reshare it, and then I can pull up the right one. And window and share. Did it come up?
No, not yet.
Come on now.
There you go.
Okay.
Now you have us up, so you need to pull up the PowerPoint.
So sorry. Ta-da, finally. Sorry about that. Okay.
All right, there you
go. So, sorry. So a couple of things I wanted to talk about real quick, and this is leading into termination. When doing fiber, always connect your pull mesh to the Kevlar fibers that are inside. If you do not, then you're liable to break your fiber, which I have an example of here. So just keep in mind, it's super important when you're pulling your fiber, never pull it by the jacketing, always pull it by the Kevlar that's inside. Best practices, clean everything. So we give you some alcohol bottle and chem wipes in your termination kit, but I also recommend using the pen cleaners. And worst case scenario, if you don't have anything on hand, have some lens cleaners in your pack. But it's just super important that you clean everything. If you do not, you're going to experience loss right out of the gate. And so it's just super important to stress that. All right, so let's talk about the Term Kit. This is going to be branded under the Platinum brand going forward. So just keep in mind that everything I'm going to show you will still be in the kit, but it will be branded under Platinum. And I think they're changing the cleave and the stripper tool in the new kit. And then also keep in mind what Mark said, that we're running the promo where you purchase 2 jars of our Easy EX ends and get the tool for free. So, all right, so I'm going to run through these and then I'll show them to you in a moment. We're going to give, in the kit, you get a set of Kevlar shears. You're going to get a a stripper tool, a 3-hole stripper tool. You get the cleave, a VFL, which is visual fault locator. I'll talk more about that in a moment. And then we're going to get our VFL adapter, which is this little part here, our chem wipes, our alcohol bottle, which, by the way, will leak. So either pour it into a jar that will tighten, or carry your alcohol bottle in a Ziploc, because it will rust your tools or leak out and evaporate. Then you need, you get a ruler. You will use a ruler, and you get a Sharpie, which you will use every time you're doing a termination, and then you get a case to carry it in. So that's the parts in the term kit. I also recommend add-ons. The cleaning pens, we have an FC125, which is for LC connectors, and FC250, which is for the SC. You're going to use these anytime you have a connector laying without a dust cap. You'll also use it on SFP modules if they don't have a dust cap on them, and you want to clean those before you use them every time. All right, so here's the steps of terminating, what I'm going to walk you through, and then that's it. So I'm going to swap off here, but I will leave this up here so if you need to take a picture of it, so that you can refer back to this later. But then I'm going to shrink this down and go to the camera where you can see my hands actually doing this. Okay. All right, Mark. So that's that. If we can swap over, I'm going to stop sharing.
Yeah.
And I'm going to swap cameras, and we're going to terminate.
Let's do it.
All right. So the parts of the kit, I'm going to go ahead and show them to you. This is our VFL. So the way you're going to check your VFL is you want to point it down and make sure you have a nice circular pattern on your VFL. If you do not, if you see any black lines through it, then you need to replace it because the ceramic filaments inside of it are broken. But that's how you check your VFL. So the VFL, visual fault locator, is actually your first line of testing, right? So when you're doing fiber, you're either getting this light through it or you're not, right? So it's a go, no go. That's your first tester. All right, so I'm going to set that aside. You're also going to get this LC adapter. This just takes the end of the VFL, which is natively designed for an SC connector size, and it shrinks it down so that it is to an LC connector size. Okay, and so that's what this adapter is for. We also get our 3-hole stripper tool. So you get the outer jacket, the inner 250 micron jacket, and then the third hole is for that last layer, 125 micron. Then we have our Kevlar shears. These cut Kevlar. Kevlar is not easily cut with regular scissors. I don't recommend it. Then, of course, we get our Sharpie and our ruler. And I'll show you the cleave because that's where the ruler comes in. So a cleave is basically a measuring jig with a diamond glass cutting blade. So if you happen to be using a cleave that does not have a measuring jig, that's where you would need your ruler. Okay, so that's why there's one in there, because not every cleave has one. But this basically has a ruler portion written on it. And then as you can see here, it has a blade. That's your diamond glass cutting blade. But that's all a cleave is just a measuring jig and a glass cutter. Now, and then we have our alcohol bottle. Like I said, be careful, it will leak. And then we have our box of chem wipes. All right, so that's all the components that come in the term kit. And so I wanted to just quickly point out the difference in the connectors and show you the components of the connectors. So these are LC connectors. This is an SC connector, and this is the ST. Now, each of these has a dust cap. It has a viewing window. Inside of that window is gel. And when you bring the fiber into there, it's going to connect it like this. And that gel is in there to hold it in place. So these are re-terminable up to 5 times. After 5, you've kind of removed enough of that gel that it's no longer going to be viable. So that's what's inside of there. You'll also be able to see when you're doing the termination, this will be plugged into the VFL. And when you get the fiber in there, that will change or dim. So you'll see that when I demonstrate it in a moment. Then you also, this portion here is called a boot, And then on the SC connectors, they have buildup tubes. But that's the parts of the connector with those. So I'm going to show you a demonstration of terminating the fiber on some single mode distribution cable. So before we get started, I just real quickly want to point out some interesting, helpful information on the actual fiber. So on our fiber, every 2 feet, you will find the information for the fiber printed. This is handy because it's got valuable information you may be asked about on your project. So example, this one says TechLogix Networks Ecofiber OFNP, which stands for optical fiber non-conductive plenum. So if you're project manager or someone is inspecting and asked if this is conductive or non-conductive, that's where you can show them that. That's what that means. This also says that it is plenum, 2 fiber, and that it has a series of numbers. This series of numbers changes every 2 feet. It's called a foot marker. The reason that's important is if somebody else pulled the fiber and you did not, and you need to know the length, this foot marker, you can go to the ends of the fiber, get the numbers, do the math, and you would know within a couple of feet how long that run is. And then it also says, that it's UL rated, that it's plus Corning SFP Ultra Optical. That plus Corning, like I said, it's super important that you can identify that it's Corning, because that lets you know immediately that it can be fusion spliced if that is applicable. And then it says fiber 9/125, which tells you it's the core size and that this is single mode. Anyway, all right. So what we're going to do with terminating is we're going to measure out about 5-6 inches of the jacketing, and we're going to go ahead and strip that off. Inside here, you'll find 2 strands of fiber and your aramid fibers. So what you would do if you were pulling that is you would tie these off and you would pull them. In this instance, we don't need that, so we're just going to go ahead and remove that. So we have our 2 strands of fiber. I am going to actually use an SC connector because most people I find are kind of intimidated by the SC connector because it has a lot of parts. But I want to point out these extra tubes are just buildup tubes, and they're only there for strain relief, right? So you can see the ends, the differences in the diameters of the holes. So you just want to use whichever one's comfortable for the application that you're using. The black one is the smallest, and that would be for that micro distribution or your OSP that is down to the very last layer of the fiber, and you need that strain relief. In this instance, I'm just doing a regular SC connector, so I'm just going to use the white one. So I'm going to take that and I'm going to put my boot on first, and I'm going to add my strain relief, and I'm going to set that aside for 1 moment. Now on the VFL, we're doing an SC connector, so we don't have to add the adapter. So I'm just going to turn it on, and I'm going to remove the opening jig. That's what this little black piece is here. It comes on both the LC and the SC connectors have an opening jig. I would recommend that you keep one of your bags that the connectors come in and use it for spare parts, because if you need to re-terminate this, you're going to want to put that opening jig back on to open it back up.
Is that the official technical term for it? Opening jig?
As far as I'm aware, I don't know of any other name for it.
It's just funny.
If you've got another name, Mark, just for you, I would adopt it.
I'll think about it. All right. And you get back to them. Yeah.
So you plug in the connector into the end of the VFL, and as you can see, it lights up the window. So we have that. So we're going to set it aside, and we're going to come back to our fiber, and we're going to take that packaging and we're going to lay the strands down on the packaging. Now, what we're looking for, if you look at the packaging, this section here is mimicking the actual jacket. Then this 20 millimeters will be the space in between from when we cleave it down there'll be a section of that 125 micron layer that we will leave on there for strain relief. That will be within that. And then this 10 millimeter is actually what we're going to end up with of bare uncovered fiber. So what I do is I like to mark these, giving myself a little bit of room off the end. I leave a little extra, and I leave a little extra off the other end. That way I have room to work with it with the boot on, and it won't be really tight. But then I also have room at this end so that I can get a feel for the fiber with my stripper tool, because most often people will break the fiber right off the bat because they just, you know, they'll grab it too hard or put it in the wrong place, and it'll just crimp it right off. So I give myself a little room to play with it or get used to it before I get into the area that I'm actually working. So we're going to mark that right on the 10 millimeter and the 20 millimeters. So we're going to mark it on both sides of the 20 millimeter. And so now we're going to come back with our stripper tool, and we're going to do the orange one because that's the one I put the boot on. And so this is the best way I have found to do this without breaking or peeling off the undercoating, because as I mentioned, when we get down into this area, we need that underlayer to stay for strain relief. And so the best way I have found is to grab onto it in about 10 millimeter increments. If you just come down here where the black is and you try to strip that off, it's going to catch on that undercoating, and you'll see your fibers start to bend, and then it will just break on off. So you just can't do it that way. So I have found best practices to grab it at about 10 millimeters, not bending it. It's just in there in that second groove, and you yank it off. And you just want to do that a little bit at a time. I just broke it. See, it's easy. You got to lay it in that groove, but that's why I gave myself extra space, right? So you grab it and yank it off, and you just keep doing that until you work your way down to the first black line. Okay, so now we have stripped off that 250 micron layer down to the first black line. Now we're going to come in on the third hole, and you want to make sure that it's seated in the groove properly. And so there's no tension on it. It's not bent, nothing special. And now we're just going to, in one smooth swipe, pull that off. And you can see that 125 micron layer came off. So now we're just going to gently rub our fingers on there and make sure it's clean. Now, if you forget to take this layer off and then you start to cleave it, it will not cleave. It will not cut it. So if you get into stripping this and then you start to cleave and it won't cut, go back and strip that layer off, because that's more than likely what the problem is. All right, so now we have this ready. And we have stripped off both layers. Now we're going to bring in our cleave. And at this point, I'm going to tell you that you want to have your trash can on here and you want to use it, because although the fiber that we use today is safer and easier to handle, it's still glass. You can still get it embedded in your finger, your tongue, your eye. So you want to be respectful for it. You don't know who's coming after you, and they might touch it and get it in their eyes. So always be respectful of it. So now I've got this lined up right here at the 10 millimeter on this measuring jig. There's a 10 millimeter mark. I have the jacketing lined up with the 10 millimeter. I'm going to close it down and cleave it. And there, it fell right into the trash can. And now we have 10 millimeters of bare raw fiber. Okay, so now we're going to come back in with our stripper tool on that middle hole. And we're going to yank that off. And now what I want to point out and show you is you can actually see both layers. Let me get it where it'll focus. See that layer? That 125 micron layer is still on there, and then the raw fiber. So we're going to go ahead and strip all the way down to the next black line. So now we have our 10 millimeters of raw fiber, and we have 20 millimeters of 125 micron layer, and then we have the jacketing. So now it's time to clean. So we take our chem wipe and our alcohol, and we want to clean off where we've been handling this, because it's super important. If you don't clean this, then all of your fingerprints, the oil, everything is going to immediately cause loss once you terminate this into your connector. So now I'm going to take the fiber and I'm just going to insert it into the ferrule, which is the end white piece there. And we're just going to put it in there. And what we're watching for is for the light to change or dim. Hello. See that? See that change? So once we see that, we just press down on that window and it snaps. You'll feel it or hear it click into place. And as you can see, it grabbed on. And then we pull up our strain relief. And then we pull up our boot. And we screw on the boot. And we're done. That's it. So we've made our termination. Now, you see this is glowing a little bit here. That's not unusual. And when we look at the other end, we have our bright red light coming out of the other end of here because we've made a successful termination. Now, one thing I do come across often is that people will say, well, when I'm out in the field, my fiber is not glowing as bright as it did when you showed me in training. Well, that's because the end of this is crushed, right? It hasn't been cleaved properly. So you'll see a little bleed out on the end of here. That's okay. It's totally normal. Really, sometimes it can vary where you'll see it bright like that, or you'll see just a red dot. It's okay either way. As long as you're getting the red light through, tells you that you've made a successful termination and your fiber's not, usually it means it's not broken in there. But that's it. So you would just remove this and you would put your dust cover back on, and that's terminated. Any questions? One thing I do want to point out is that everything I just showed you for that is the same exact measurements for the LC connector as well. So I could literally take this one off right now, clean it, and put on an LC connector, and it would work exactly the same. So everything you learned for LC is applicable with the SC and the LC. They're interchangeable, and they perform exactly the same. It's just the equipment is what decides which one you want to use. Like, for example, here's an SFP module. So if you were using an SC, you would only have one plug-in, right? But because we're using this one as an LC, we would get double. And that's why people like the LC. So it just, everything's the same. It's just the equipment is usually what decides which connector you want to use. But
Robin, Philip has a good question. This may lead into kind of what I was thinking too. So if single mode is run into the house,
yes.
I mean, he asked if you can like splice it into multi-mode, but I guess
so
the answer be, is there a electronics where you can, piece of electronic where you can pull it out into multi-mode, right?
Yes, absolutely. So there's a couple of ways. You're going to come into the house with single mode. So what are you going to do? You're either going to put it into a box. At that point, you would have to convert it in some way. But if you bring it in and you plug it into a switch, and then you use an SFP, that's maybe you're bringing in single mode, you're plugging it into the switch, you can use a multi-mode SFP and then come out of the switch with multi-mode, right? Or we also have media converters. Now, this one is not what I'm talking about, but I want to point out, see how this has an SFP module on it? We actually have a media converter that has 2 SFP ports. And you can come in with single mode and come out with multi-mode. So you can convert it that way also. So if you're using a switch, you can convert it easily in the switch just by using a multi-mode SFP. And then you would run multi-mode. If you come into the building with just fiber and you don't plug it into any equipment at all, then that's a little more complicated. It really, you can't go from single mode to multi-mode. One of the examples I always use is, think of it this way. Multi-mode is like a drinking straw and single mode is like a coffee straw, right? If you try to pour liquid through them, it doesn't work. It's the same thing with the light, right? If you tried to plug in a single mode to a multi-mode, it's just not going to work. It will bleed out. It doesn't work. So you have to have a way to convert it. But yes, there are plenty of ways.
That's great.
All right. Well, that's all I have for you today, sir. If you have any questions, I'm happy.
So we got how sharp of a bend can it? Oh, that's a good question. I guess it's durability.
It actually, it has a really nice bend radius. So in my other certification training, you definitely, it points out that you have like a 0.4 millimeter bend radius. Now that's within that jacket. And even in the individual strands, it bends really nicely. The only time you encounter a problem is if you do like a hard 90. I have tried purposely to take just the raw fiber and snap it. And it took me, it took some effort to snap it. But then again, it's very delicate. So it's like glass. If you were breaking a mirror, you might have to put some effort into breaking the mirror, but then again, you might just bump it and it crack. It's the same thing with this. It's pretty durable and it will bend. It's got a really nice bend and insensitivity. But at the same token, if you don't protect it like this and you leave this hanging, that could snap it. So you just want to be careful with it. Don't you leave a service loop on your job. Try, if you get an opportunity, put it in a box, a termination box, because it's going to protect your project. So that's what I would recommend.
Well, now, Robin, we wanted to say bye because it's the end of the show.
I love it.
Rob and I have gone back a long time, so we worked together at another company, and there's nobody else I would rather end it with than with Rob and Roy. So thank you so much.
You're actually in my phone. You're in my phone as Mark the Shark. Yeah.
Yeah, that's right. My kids wanted to say bye to everybody since this is our last training. So
all I can tell you is if you run into any issues and you need help, just give me a call. I'd be happy. I can get on a video call with anyone and help you. Mm-hmm.
Robin, there's a bunch of people out here that do want some hands-on training. I did see a couple people actually in Tennessee. I know you're in Tennessee. Mm-hmm. So let's get that scheduled so they could actually hands-on terminate it would be awesome. So we can set that up.
Yeah, absolutely.
Thank you, everybody.
All right, have a great weekend.
For an amazing time. I really appreciate everybody's support at 21st Century. And make sure you guys keep staying in our arcade all weekend. See the recorded trainings. Check out the live or the booths at our in our main hall. And we really appreciate you guys and your support, 21st Century. Say bye, everybody.
Thanks, everybody.
Take care.